lesson we actually did addition of binary numbers. So in this lesson, what we are dealing with is the application of binary number systems. All right, so this question was taken from 2007, question 9. The question is, if x base 10 is equals 1, 2, 1, 4 base 5, the question is to find x. Now the first thing that should come to your mind is, if you remember, for this equation sign, whenever you see an equation sign, it means the left hand side is equal to the what? Right hand side. So whatever we have on the left is equals to the right. Alright, so the first thing I need to do, since this is in base 10 and this is in base 5, the quickest route you can go through is to convert this number that is here, this base 5 number, convert it to base what? 10. You know, in our first lesson, if I've not watched it, go and watch it again. I talked about several other number system apart from base 10 and base 2. Now this is a very good example of such thing I said. So the way I can convert base 5 to base 10 is the same way I did for the conversion of base 2 numbers to base 10. How? This is already what we don't know. Now for me to convert this is basically, I'll take this number that is here that I'm converting, 1 times the base number, which is the base number in this case is 5, to the power of the number of the position, that is 1, 2, 3. That's 5 raised to the power 3. Plus, it's always addition. Do not go for subtraction, it's always addition. Plus, then you go for the next number there, which is 2, times the base number, always the base number. Now when it was base 2, we had to use 2, but for this case it's base 5. So 5 raised to the power 1, 2, right? Plus, the next number there is 1, times 5 raised to the power, after 1, just a one number that's there, that's 1, plus the last number there is 4 times 5 to the power of 0, right? So if we remember, whenever you multiply this number by 1, it's the same thing. That's 5 raised to the power 3 plus. So this should be times, let me just rewrite it here, plus 1 times that number is the same thing, 5 raised to the power 1. Anything raised to the power 1 is the same number, okay? Plus, remember this, we said whenever any number is raising 0 to the power, it becomes 1. So it means this is 1. 4 times 1 is what? 4. Alright. So 5 to the power of 3 is 125. That's 5 times 5, 25. Times 5, that should be 125. Plus 5 raised to the power 2 is 25. Times 2, that's 50. Plus 5 plus 4, that's 9. So I should be having something as sorry for that distraction. So this should be 125 plus 50, that's 175, plus 9, that should be 184. Okay, so this is the final addition that we have to go through to get our final answer. Like I said, this conversion process is the same thing as when you are converting from base 2 to base 10. So since we know that this is s base 10 and this is a number in base 10, it means therefore x is equals what? 184. All right, it means x is equals 184. So the same conversion process, whenever you're converting any number, whenever you're converting any base number to base 10, this is the process you follow. All you just have to do is the numbers that are there, 1 times the base number raised to the power of the positions after the number. So after this number we have 1, 2, 3. After this number we have 1, 2. After this number we have just 1. Alright, that's how to go about it. So I want this video to be very short. So I'll see you in the next lesson. I think the next lesson should be the concluding lesson for binary numbers. So these are the things you need to know for JAMB. Alright, this is the syllabus, the whole syllabus for JAMB as pertaining binary numbers. So see you in the next lesson.